Okay, this section's on 6.3, integration by parts. I'm going to call it the repeating one, though. This is still by parts, but what we're going to find out is in this equation, it's going to start to repeat. And so there's a little trick behind that. So we're going to work on that one. So since it's doing still by parts, we still are going to use the acronym of the lipid on the side for the U sub and etc. Okay? So let's go ahead and do this. So I'm going to go ahead and do a little U setup right here. My dV, my du, and my v. So between this is going to be my e, which is the exponential, and this is my trig right here. All of this is trig. So between the e, which is exponential, and trig, e comes before trig, so we're going to go ahead and choose the e as my u. So here we have then is e to the negative x, and so the remaining part of it, the integration of cosine 3x dx, is the remaining part right there. So we have is then the derivative of EU is EU times the derivative of U. That's the little chain part of it. So we have is negative e to the negative x right there. And then this right here, when I take the integration of this is actually requires a U sub because there's a little 3x right there. So we have to do a little U sub. There's a lot of things going on in this problem. So we have then is a U sub. So we have is 3x as my U sub. So then derivative of that becomes du equals, and then we have as 3 dx, and then we're going to bring the 3 over, so that becomes 1/3 du is equal to dx. So let me rewrite that. So really what we're doing then is the cosine of u, right? And we're going to substitute that du part of it. So that's the du, and then the 1/3 is a number, so it's 1/3 like this. So this is really what we're taking the integration of. So that makes it simpler for us to take the integration. So the integration of cosine, so remember cosine is right here, so we're going up on integration, that becomes sine. So then we copy the 1/3, and it becomes sine u, which I can always go ahead and put that back as my 3x right there. Okay, so we have a lot of things going on. We take the derivative, right, and then we also have is the integration with the u sub. So you got to do everything that we've known now. So we go ahead and multiply across and over. So let's set that up right here. So I have is then equals, let's see, 1/3 e to the negative x. So 1/3 e to the negative x, and then we have a sine 3x. So sine 3x, and then minus, because again, remember that's the formula for by parts, and then we multiply over. So since the over part right here, this is the negative right there, so that's going to give us a positive right here. So that's positive, the integration of, and then again, that 1/3 is a number. We can probably pull it up in front of the integration symbol right there, e to the negative x, and then becomes sine of 3x dx. Okay, oops, I forgot a dx right there then. Okay, so again, this is similar to what we just did in part 1. This is not complete because it needs to be a simple integration. If this is not a simple integration, we do it again by parts again. So we do it again right here. So I have then by parts again is u is equal to e to the negative x. My dv is equal to the integration of sine 3x. So then du is equal to negative e to negative x again, because that's that derivative of e. V is equal to, now again, this is similar to what we just talked about up here. That u sub right there, that 3x is our u sub right there, it's still going to become my u sub right here. So the trick of this is, it's still, this is going to not change right there. The only thing that's going to change is this integration of the sine and cosine thing right there, okay? So I still have is that 1/3 right there. So technically, if you redo this, it's like saying the 1/3 of the integration of sine u, right? So I could just copy that 1/3 down again because it's going to become the same thing right there. The integration of sine, because sine is up right there, and so when we take the integration, it's going to come back down, so it becomes negative, right? Cosine of 3x right there. Okay, so we multiply across and we do over again, so then we copy that part right there. So then I have is equals 1/3 e to the negative x sine 3x Now here's where we have to pay attention. So I have as a plus 1/3, so that's plus 1/3 right there. I'm not going to touch that part right there. But again, it's the integration, this part right here, the integration, actual integration is what we're substituting with the parts by. So then I'm going to keep it as my bracket right there. I have, let's see, a negative 1/3, so that's going to give me a negative 1/3 e to the negative x, and we have as what, cosine 3x minus, because again, that's formula right there, so the integration of, and this is negative and negative, so that's positive, so that's going to give positive times negative is negative, so this one stays then, okay? And then the 1/3, we can pull it up in the front again, so we go 1/3 e to the negative x, and then we have his cosine 3x dx again, oops, again, I forgot that dx. And then that's it right there. Okay? So again, we multiply it across and over right there. So the across part right there, that gives us negative 1/3. So that's this part right here. E to the negative x, cosine 3x. And then the over part right here, that's negative and negative right there. That gives us positive. Positive times the negative, that was formula. It's just negative. So that one stays right there. And then we still have is that 1/3. So I pull it up in the front. I have is e to the negative x times cosine 3x right there. Okay, so here's the problem. You see this part right there? That still is not a simple, not like the last part that we did on part 1. This is still repeating right there, so you would have to do it again. But pay attention, because if you actually look at this, because I know you were just sighing about that part right there, but if you pay attention, e to the negative x cosine 3x is actually the same problem as the original that we started with. This is why I say this is a repeating integration by parts. So if it happens like this, let's go ahead and simplify this right here. There's a trick behind that, so I'm going to show you that little trick right there. So then we have is then the 1/3 e to the negative x. I'm going to get rid of all that parentheses and brackets and all that stuff right there. So let's just simplify that right there. Okay, so here we go. Then I have is, right there. So I have to distribute this 1/3 into all of the second part of that bracket right there. So that's going to give us what, negative, so it should give us negative 1/9, right? So negative 1/9 right there, e to the negative x, and then cosine 3x, and then 1/3 again times this right here gives us a negative 1/9 again. So negative 1/9 integration of e to the negative x cosine 3x dx right there. Okay? And again, we're going to set this equal to the original problem. And the original problem was e to the negative x cosine 3x dx right there. So the original problem is this right here. And we're saying this is what I got to right here. And we said, wait, this right here is the repeating of the original problem right there. So here's the trick. We're going to take all of this part right here, and we're actually going to bring it to the other side of the equal sign. So if I can drag this thing right here, bring it over here, right? We're going to bring all of that right there. So since this is negative 1/9, we're going to add 1/9 on this side right here. So then it becomes 1/9 integration e to the negative x cosine 3x plus the original problem, which is this part right here, the integration of e to the negative x cosine 3x, forgot dx on this one too, dx is equal to, and then whatever was left over right here. Okay, so we're just going to copy that right here. So the 1/3 e to the negative x sine 3x dx, oh no dx on that one, going dx happy now, minus 1/9, right? E to the negative x cosine 3x right there. Okay? So we're going to do a little fraction adding. So this is 1/9 plus 1 basically. So if it's 9 and that's a fraction of 9th, so we're just going to go 9 over 9, right? So that's 10/9. So really then it's like 10 over 9. The integration of e to the negative x cosine of 3x is what we have right here, dx. On this side of the equal sign, because I just added these together right there. The two functions right there, we add them together, so that becomes 10/9 over here. And then I still have is this part right here. So let me recopy that right there. So it's going to be 1/3 e to the negative x cosine, sine 3x and then minus 1/9 e to the negative x, and then cosine 3x, right? Okay, so what I need to do is then set this original to the original equation we said was this is the original equation. So to get rid of is what we need to get rid of is the 10/9 right there. We need to get rid of that because basically we just want it back to the original format what it was right here. So to get rid of 10/9 we just need to multiply by the reciprocal, and the reciprocal of 10/9 is what, 9/10. So we just need to multiply everything on this side right here with 9/10 instead. So if we multiply everything on this side right here with 9/10, then we're done with that, because then if I multiply by 9/10 on this side right here, 9/10, right, this cancels out and goes to 1 right here, which we want, okay? So then your final then equation comes out to integration of e to the negative x cosine 3x dx is equal to, and so we have to distribute this 9/10 to each one of these guys right here. So let's see, 3 and 9 can be reduced, right? So that's going to become 3/10 instead. So that becomes 3/10 e to the negative x sine 3x minus, and then 1/9 times 9/10 becomes what? 1/10. So it becomes 1/10 e to the negative x cosine 3x. And then you're done. So then we need the plus c, of course, because we're done with the problem. Okay? So let me just walk you through quickly, because this is a long process right here. So we have as the original equation right here. We still had to do by parts. So that's what we did by parts right here. We chose e to the negative x by using the Lippin method. E comes before trig. So that's what we did right there. So we multiply across and over, right? Across and over. But don't forget, you do a little u sub on the side because of that cosine 3x right there. So that's what we got right here. And then we found out we had to do it again by parts, was as usual. So we did it again by parts right here. So we did the same thing. We copy everything, the first part right there, and we copy the plus 1/3 because 1/3 was pulled out right there. So we copy the 1/3. The actual integration part of it, that's the product of this part right here. But then we also notice that this right here is never going to stop. This is never going to get to that simple integration part of it. But then we also notice that this is the original equation that we started with. So we set then this whole equation equal to the original problem that we started with. So we realized then we can bring all of this right here over to the other side of the equal sign. Oh, after you distribute that 1/3, don't forget to simplify everything. So bring it over on the other side. Then we add the two functions together. So this is 1/9 and plus 1. So we made that 9/9. So we added that together, gave us 10/9 instead. And so then this becomes the actual problem right there. So then again, this remains right there. So we just copy that part right here. And we want to get rid of is the 10/9 now. So we just multiply by the reciprocal, and the reciprocal is 9/10. We got to do on both sides of the equal sign, just like our algebra rule. So then from here, I just distribute the 9/10 to each one of those inside the brackets to get rid of the brackets, and that comes out to this right here, and then the plus c because we're done with the integration. So that becomes that final part right there. So it is a little tedious, but it is, it's a simple process once you get the integration by parts down. Okay, so go ahead and try these kind of problems now.